Okay, so let's look at simplifying radicals. Now, what is a radical or a square root? Okay, if we look at the square root of 25, a lot of us know that it's 5, but why? If we break this down, what times what is 25? Well, 5 times 5. Remember, a square root has to be a number times itself because it's the opposite of saying 5 squared. So we would circle that group of 2, and for each group, 1 comes out to get that answer of 5. So let's look at number 2. On number 2, we have 81. Well, a lot of us know that the square root of 81 is 9. What happens if I break it down to its prime factorization? If I break it all the way down, I get 3, 3, 3, and 3. So if I circle those groups of 2, I have a group here and a group here. For each group, 1 comes out to get 3 times 3, which is 9. So what's the process here? First step, break it down. Second, circle groups. And then third, simplify it. So let's look at another one. Now I want you to try this one in your calculator. What is the square root of negative 144? Did you get a domain error? No can do? Won't do it? Ruh-roh. Why is that? Because with a negative, what times what gives you negative 144? Well, positive 12 times positive 12 gives you a positive 144. Negative 12 times negative 12 gives you a positive 144. The only way to get that negative is a negative times a positive, but those aren't the same thing. So you can't take the square root of a negative. That's going to give you an imaginary number. You're going to learn a lot more about those next year. For now, all you have to know is you can't take a square root of a negative because it gives you an imaginary. Now, what if it doesn't have a perfect square? Look at number 4. So with 8, we're going to break it down and see what happens. So what times what is 8? 4 and 2. 4 goes down to 2 and 2, bring that other 2 down. That's our prime factorization. If it helps you to write it inside the square root, you can. Sometimes that helps people organize it. So we're going to circle our groups of 2. So we have a group here, and then the other guy doesn't have a friend. So we're going to pull 1 out for each group. So pull 1 out, and then anyone not circled stays inside, and that's your simplified form. Let's look at another one. What happens on this one? If I break this down, what times what is 62? Well, it's an even number, so 2 has to go into it. So I have 2 times 31. Well, what do you know about 31? It's a prime number. I can't break either of these down, and neither one gives me a group. So for this one, it is possible to not be able to simplify it. Try this one. Go ahead and pause and try this one. All right, how'd you break 215 down? Let's see, 5 I know goes into it because it ends in a 5. So that would give me 43. Oh, those are both prime, which means I can't simplify this one. Now you can also have numbers and letters. It works the exact same way. So the first thing you're going to do is break down that number. So this one, I'm going to do 25 and 6. Break it down to the prime factorization, just like we had done. Now I'm going to bring down my x's and y's, my letters. So we have x squared, which means we have 2 x's, and y to the third, so I have 3 y's. Now I'm going to circle my groups of 2. So I have a group of 5's, group of x's, group of y's. Pull a 5 out, because that's a group. Pull an x out, because that's a group. Pull a y out, because that's a group. Now what's left inside? I have a 2, a 3, and a y. I'm going to multiply everything on the outside, so 5xy. Multiply everything on the inside, 2 times 3 is 6, and then a y. And that's your simplified form. Go ahead and pause the video. Try this one. Did you get stuck? What's the difference on this one? This one has that little 3 in the chair. What does that do? All the other ones were square roots, which means groups of 2. That little 3 in the chair says, well, this is a cube root, which means we need groups of 3. So we're going to break that 16 down just like we normally would. Go all the way down to the prime factorization. List out your x's. List out your y's. But this time, we're going to circle groups of 3 because we have a 3 in the chair. It's a cube root. So I have a group here, and a group here. Same rule applies. Pull 1 out for each group. So pull a 2 out, pull an x out, pull a y out. Anything that wasn't circled stays inside. But remember, we have a little 3 on top of the chair. So multiply your outsides, 2xy. Multiply your insides, 2y squared. Remember that 3 in the chair because it's a cube root, and there's your simplified version. Now what happens if there's a number out in front of the radical? Okay, we're going to do basically the same thing. We're just going to have that number to multiply with whatever we pull out. So what times what is 75? Think of quarters, 3 and 25. Break down that 25, bring the 3 down. This one doesn't have anything in the little chair, so we're going to circle groups of 2, so I have a group of 5s. Here's what you have to remember. Bring the 3 down. Pull out your groups. I have a group of 5, so I pull a 5 out, and then I have a 3 that stays inside. And then same process. Multiply what's on the outside, multiply anything that's on the inside, and there's your simplified version. You guys try number 10. All right, so you should have broke 72 down. What times what is 72? We have 9 times 8. If you broke it down differently, totally fine. This gives me 3 and 3. This gives me 4 and 2. I can go one more step with that 4, 2 and 2, 2. Bring down those x's and your y. So this is a square root, so we need groups of 2. But remember, we got to bring that 6x down that's out in front. Okay, I'm going to circle my groups of 2's. Pull 1 out for each group. Anything that didn't have a partner stays inside. Multiply everything on the outside. So 6 times 3 times 2 would be 36. X times x is x squared. Multiply what's on the inside, and there's your simplified version. Now we have one more thing to look at, and that's when we have a fraction. So what happens when you have a radical with a fraction? That radical is actually going to split up, and it's really the square root of the top over the square root of the bottom. And splitting it up can make your life a lot easier. For this one, it turns out really nicely, because what's the square root of 25? 5. What's the square root of 9? 3. So this one's simplified down to a nice pretty fraction. What happens if it doesn't, though? Look at this one. When I split this one up, I get the square root of 4 over the square root of 6. Well, the square root of 4 is 2, but I don't have a square root of 6. And if I break that down, I can't even simplify it. Well, this is bad because you're not allowed to have a radical in the denominator. So we're going to have to rationalize the denominator. That means we're going to get the radical out of the denominator. Now we're talking groups of 2. Right now I have a 6 on the bottom. Well, I need 2 of those in order to make a group. So what we're going to do is multiply by what we need. I have 1 6. I need 1 more. Anything I do to the bottom, you have to do to the top. So what happens here? This gives me on top 2 radical 6, and on the bottom, radical 6 times 6. Well, doesn't that give you your nice pretty group of 2? So really on the bottom we have 6, and on the top we have 2 radical 6. Now here's the deal with simplifying. The 6 on the bottom is not inside a radical. So if you're going to simplify, you have to look on the outside of the radical on top with the number that's not in a radical on the bottom. This one does simplify. We can pull a 2 out of top and bottom to get radical 6 over 3. Let's look at another one. So here's this one. So if I split up my top and bottom, I have the square root of 5 over the square root of 12. Now you have two options here. You can either go ahead and just rationalize it how it is, or you can simplify it. I will do it both ways. You can choose which one you like better. So I could just go ahead and simplify. I can't do a radical of either of those. Neither one has a square root. So I have a 12 on the bottom. I need groups of 2, so I'm going to multiply by radical 12. Anything I do to the bottom, I have to do to the top. Well, what happens there? On the top, I get the square root of 5 times 12. On the bottom, I get the square root of 12 times 12. Well, that gave me a nice pretty group on the bottom, right? So on the bottom, we have 12. On the top, you have to simplify. So 5 is prime. 12 breaks down to 4 and 3, which goes to 2 and 2. So you do have a group of 2's. I'm going to pull that 2 out. And then on the inside, I have a 5 and a 3, so square root of 15. Now remember, I can look at these numbers right in front with the bottom to simplify. I can pull a 2 out of top and bottom to get radical 15 over 6. Now, if that seemed complicated, let me show you another way to think about this. On the second part, I can't simplify 5. That's prime. But on the bottom, I could simplify 12 to 4 and 3, which goes to 2 and 2 and 3. So there's my group of 2. So really on the bottom, we have 2 radical 3. Okay, so I only need to get rid of the radical, so I only have to look at what's inside the square root, which is a 3. I have 1 3, I need 2. So I'm going to multiply by the square root of 3. Anything I do to the bottom, we have to do to the top. So what happens? On the top, I get the square root of 5 times 3. On the bottom, I get 2 square root of 3 times 3. Okay, so on the top, I have 2 prime numbers, 5 and 3. I can't break either of those down, so I'm going to simplify it to square root of 15. But on the bottom, I have a group of 3's. And for every group, we pull 1 out. Don't forget about that 2 out in front. 2 times 3 is 6. We just got the exact same answer.